Everyone, myself Dr. Feroza Demirajkar, and today we will see a 8051 program to transfer 10 bytes of data from the internal RAM to external RAM. So the purpose of the program is to transfer 10 bytes of data from internal RAM. Here we are taking the address starting at 30H to external memory, which is starting at an address 0040H. You can change the address accordingly. So the steps are, first is initializing the loop counter and the pointers. Then we'll use a loop in order to transfer the data byte by byte. Then we'll halt the program when the operation is complete. That is when we are able to transfer all the data from the memory location, that is the internal RAM location, to the external memory location. So here I have taken this data at 10 memory locations starting from 30H to 39H. That is at 30H I'm storing 11, 31H 22, and so on up to 39H. We are storing these data. These are before execution, and here we want to transfer this data to 0040H. That is starting address is 0040H for the external memory. Initially, before execution, the data present in these locations is 0. Now after execution, this data which is present at 30H, 31H up to 39H, this will be copied to the memory locations 0040H, 0041H up to 0049H. Here the data which is present at 30H, it will be transferred to 0040H location, that is 11 is transferred to this location. Similarly, we'll transfer 22 from the internal memory to the external memory location. Then we'll transfer 33, 44, 55, 66 and so on up to last is 0A, which is at 39 to 0049H. So these are some of the instructions which we are using here. First is the move, which transfers the data between the registers, memory or immediate values. Then we have move X, it transfers the data to or from the external memory. Then we have INC, which will increment the value of a register or a pointer. And you have DJNZ, that is, it will decrement the value of a register and jumps to the specified level if the value is not 0. And we are using SJump, which is unconditionally jumps to a specified level. Now we will see the program. The first, that is the directive is org0000H. So our program starts at this memory location. Then we have move R2, R2, hash 0AH, which will load the register R2 with the value 0A, that is 10 in decimal. Then we have move R0, hash 30H, which will load the register R0 with the value 30H, that is address in the internal RAM. Then we have move DPTR, hash 0040H. It will load the DPTR, that is the data pointer, with the value 0040H, that is the address in the external RAM or the data memory. So what we are doing here, we are initializing R2 to serve as a counter, that will the loop will execute 10 times. Then we have R0, that is initialized to point to the start of data in the internal memory, that is RAM. And we have DPTR is initialized to point to the start of external memory at an address 0040H. Then we have a loop where we will transfer the data. So here we have up colon move A comma at R0. Here we are using the label up, and first instruction here is move A comma at R0. So here it will move the value from the internal RAM address pointed by R0 into the accumulator A. Then we have move X at DPTR comma A. So here it will move the value from the accumulator A to the external memory address pointed by the DPTR. Then we have increment R0. So here it will increment the R0 to point to the next internal RAM address. Next is increment DPTR. So it will increment the DPTR to point to the next external memory address. Then we have DJNZ R2 comma up, where here that is it will decrement R2 until and unless it becomes 0. If it is not equal to 0, then it will jump to this level up. Then at last we have what? We have an infinite loop, that is the end of the program. So here this is a infinite loop to halt the program, and this is the result before execution. Okay, at 30h we are giving, or we are entering this data. You can enter different data also. Then we have 0040 h, that is the external memory location. So initially we don't have any data here. Once we execute the program, this data will be copied to the external memory location. This is the step-by-step execution of the program. What we are doing is, first we are initializing. Okay, first step is initializing, that is we are setting R2 to 0, R2 to 10. Okay, so here this will serve as a loop counter for 10 iterations. Then we have R0, that is equal to 30h. It is the starting address of the data in the internal RAM. Then we have DPTR, which is 0040h, that is the starting address of the external memory. Then we have the second step, wherein we'll start the loop. Here we'll read the value from the internal memory address, which is pointed memory address pointed to by the R0, and it will store it in the accumulator A. Then we'll write the value to the external memory address pointed to by the DPTR, that is the value which is in the accumulator. We will write that to the external memory address pointed to by the DPTR. Then we will increment the DPTR to the next byte in the external memory, and will increment R0 to point to the next byte in the internal RAM. Then we'll decrement R2, reducing the loop counter by 1. Okay, and step 3 is we'll repeat this until R2 becomes 0. Therefore there will be total 10 iterations. After that we will enter the infinite loop at the label H. Now we will see the execution of the program. So here I will directly copy the program. Open the Keel software. Maximize it. Go to project, new Vision project. I'll use the previously used project. Yes. So search for the device microchip. Then click on this plus symbol and search for 8089 C51. Okay. Then no. Now go to the file, open new file and type your program here. I'll directly paste my program. Then save this program. Here it is internal to external, so I'll save it as int to ext. Save this with a .asm extension and save. Okay, yes. Then go to target, click on this plus symbol. You will get source group 1. Right click on this and click on add existing files to group source group 1. Now search your program here. It was int to ext.asm. Okay, add and close. Now go to project, click on build target. You have 0 errors and 0 warnings. Now go to debug, click on start or stop debug session. Okay, so we want to transfer from internal to external. At memory 1 I will take I:30h. We have taken the address 30h for internal RAM, and we will select one more memory window. So here we will give the external address. So it is x colon 0040h. Now give the data here 1, 2, 3, 4, 5, 6, 7, 8, 9 and A I'll give. Okay, this data is at the internal memory location. Now it has to be transferred to the external memory location that we have taken 0040h. Now I'll run the program. So you can see here earlier the data was 0. Now you are getting it as 1, 2, 3, 4, 5 up to 0. Okay, this is a program to transfer the 10 bytes of data from the internal RAM to the external RAM. I hope you have understood the program. Thank you.